I now discuss loss ranks. They have caused much confusion in the literature, and everybody who studies rank-dependent utility has to go through this confusion, so we should discuss it. Comes to it, loss ranks will be used in the definition of prospect theory coming next meeting, so we should discuss it anyhow. Anyway, let me just to repeat and prepare. Rank, it was the probability of getting outcome rank better. Informally, I sometimes call that a good news probability. It's good news if you get something better than something else, it can never harm. And if you really study everything we did so far, and you see wherever we use this probability transformation function W, it was always applied to probabilities that were ranks. You can verify it's true. It would have been better had we called W a rank transformation or a rank weighting function rather than a probability weighting function. But unfortunately, it's too late to change terminology. But it's good to keep that in mind. With that prepared, imagine there's a critic. He criticizes the thing we did, criticizes rank-dependent utility. He says, you guys were using good news probabilities, but I think it's more natural to use bad news probability. Not the probability of an outcome ranked better, but the probability of an outcome ranked worse. Let me write it here. Let me call that a loss rank. So that is the probability of an outcome ranked worst. And the critic says, I think this is a better ingredient for a theory to develop. You guys were looking at rank probabilities. Those are pairs of probabilities where one is the outcome probability, the other is the rank. I think it's better to combine outcome probability with a loss rank. Let me then call such a pair a loss rank probability. And I think if we use this concept, I expect we get better theories. I will also use a non-additive function from 0,1 to 0,1 to avoid confusion with that bad silly theory that you introduce. I will not denote it W, I will denote it Z. Then it's quite business as usual. If I take a prospect, I take a complete ranking of the outcomes. I evaluate the prospect by a convex combination of the utilities of the outcomes, just like you did. But the convex combination weights, the decision weights, are defined a bit differently. They will be the marginal Z contribution of the outcome probability to the loss rank and not to the gain rank. And so let me write it. So this there's the decision weight. Now here I write, see, I hope that you see that this probability here is the loss rank, is the probability of getting an outcome ranked worse than xj. Now how much do I gain in terms of C if I add the outcome probability pj to it? That value is the decision weight that we use here. So this is what our critic says. And then why not do what he says? The critic may even argue that this is more natural because people are more concerned about bad outcomes than good outcomes. So this may more be capturing what goes on in the minds of human beings than what the rank-dependent utility did as we have been discussing it so far. So there's the question, what would be a better theory, what our critic says or what we have been doing? So you can think about it, make up your mind, and pause the video and then come back. But maybe I should say people have been confused about it for a long time, so you shouldn't feel too guilty if you don't really know what to think about it. But you can make up your mind already, and then after that come back. Okay, now I assume you're back. I will tell you my answer to this criticism, and my answer is, it doesn't matter. It is the same. What the critic says and what we do is the same. So to explain, let's take what the critic says with function z and everything. Now I'm going to define my w function as, we call that the dual of the z function. So wp is 1 minus the z of 1 minus p. Then it can be seen that also z is the dual of w, but okay, we believe it, we want to go on. Now, here is the decision weight that I claim we should use, and let me rewrite it in terms of Z. First, here I do the rewriting, and I hope that you see that this probability is 1 minus that probability. So indeed, this value is equal to that value, and this probability is 1 minus that probability. So this value is equal to that value. So indeed, the equality that I claim here holds. And now I just drop the ones and I rewrite and I get, this is what we have. And here you see this is exactly the decision weight that our critic said. The marginal outcome contribution, the marginal Z contribution of the outcome probability Pj to the loss rank. So indeed, what the critic did not propose anything new, but just an alternative writing of what we did. And it doesn't matter, it's quite equivalent if you do one writing or the other, it's just whatever convention you take. The field has taken the convention that we have been doing in this course. and for good, all kind of good reason. I will not discuss them now. But not everybody. There are still some people who use the alternative, who are working with loss ranks. You can imagine that gives a lot of confusion. If one theory says the weighting function is convex and the other theory says concave, the dual of convexity and concave. So it's really desirable that the field gets complete unanimity on this, and it's happening more and more. So we in this course did the way that is the convention now, and I hope everybody will always follow that convention to avoid confusions to come. But in principle, it's more or less arbitrary. We could have done one or the other, but we should do all the same. Now, the confusion that has arisen so much is partly due to a bad terminology that we have. We call W the probability weighting function, but that's an unfortunate term because probability, which probability? It doesn't say which. And in fact, W is always transforming ranks. We should have called it a rank weighting function. Then there wouldn't have been any confusion at all. Then you say, of course, the rank weighting function should be applied to ranks. That's how it's defined. You can also look at loss ranks if you want. Then you use the loss rank weighting function. That's just a dual of the rank weighting function. And everything would always have been clear and would have been better. But it's too late to change terminology, so we have to live with it. Anyway, now you understand that it doesn't matter and that we are fine in this regard. With that happy conclusion again, I end this recording.